Hey everyone, and welcome back for another deep dive. Today we'll be uncovering some pretty amazing secrets about prehistoric creatures.
It's funny, we think about dinosaurs as these massive, powerful creatures, but there are all these smaller creatures who are even more fascinating.
Absolutely, we'll be looking at one today that might rewrite what we know about complex life. But first, we're going to look at a panda, but not the typical ones we all picture.
Right. Forget those cute, cuddly bears munching on bamboo. This one was a meat eater.
Whoa, hold on. A meat-eating panda?
Yep. Arctos lufengensis, or what we call the Fengshen bear, turns that image on its head. This panda ancestor was built for speed.
I'm picturing a panda running. That's hilarious.
I know, right? But seriously, their skeletal structure, those long limbs, suggests they were more like wolves.
So they were actually hunting down prey. What were they going after?
Probably medium-sized animals. Researchers think maybe camels.
Oh, wow. So this panda was chasing down camels. Now, that's a sight I'd like to see. I guess it shows you how diverse evolution can be, even within a single family.
It really does, and it challenges the idea that evolution is this straight line. Now, ready to jump back in time? Way back.
Okay, take me back. How far are we going?
We're going to the dawn of complex life, about 1.48 billion years ago.
Wow, that's almost impossible to imagine. So what was life like way back then?
Picture an organism, a Horidischia, shaped like a string of beads, maybe one of the very first multicellular eukaryotes.
So before dinosaurs, before plants and animals as we know them, this little guy was one of the first with complex cells.
Exactly. And the amazing thing is, recent discoveries in China have found 800-million-year-old specimens of this thing, incredibly well preserved.
Fossils from a time when complex life was just beginning. It really makes you think about just how vast evolutionary history is.
It really does. Speaking of transformations, let's move on to another creature that kind of flips our understanding of evolution, an early whale relative. We're talking about Adiositis, an animal that had both teeth and baleen.
Wait, baleen? Those bristly plates whales use to filter food. But I thought baleen evolved from teeth. How could it have both?
That's the classic idea, right? But Adiositis throws a wrench in that theory.
So how could it have teeth but be a filter feeder? What's the thinking now?
Think of walruses. They use their tusks to rake up shellfish. There's new fossil evidence that Adiositis might have had a similar feeding strategy, using its teeth to sift through sediment or maybe filter small organisms.
So like a missing link in whale evolution, showing us a kind of in-between stage from toothy ancestors to the baleen whales we see today.
You got it. It gives us a more complex picture of how baleen evolved, not just a straight line from teeth to baleen. Instead, there's this back and forth between what a creature looks like and how it works.
It really shows how much studying these ancient creatures can teach us. Okay, ready for another prehistoric surprise? This one involves a predator that might have been a bit more polite than we usually think.
Ah, yes. Let's talk about those ancient relatives of crocodiles, the pseudosuchians. We picture them, I'm sure, teeth bared like crocs today. But some researchers think they might have had lips.
Lips? On a predator like that, that's hard to imagine.
I know, it changes those classic images, doesn't it? But there's actually some good evidence for this. Scientists are looking at the angle of the teeth, the way the pores are arranged on their faces, even tooth wear patterns and size.
So it's not just a guess, they've got something to back it up.
Right. And even though it's not totally proven, it does make you think about how we picture these animals.
Amazing how research can totally change our perspective, even on creatures we thought we knew. Okay, I'm ready for our final prehistoric surprise. What have you got for me?
This one might make you squirm a little. We're talking giant snails, prehistoric humans, and some interesting food choices.
Giant snails.
Oh.
Okay, now I'm curious. Tell me more.
Picture this. Giant African land snails, some as big as a kilogram, on the prehistoric menu. Evidence from Border Cave in South Africa shows that early humans were eating these snails for at least 100,000 years.
Wow. 100,000 years of snail eating. But hold on, were they just slurping these things down raw?
Actually, there's evidence they cooked them. Researchers have found differences in shell color suggesting they were heated.
Wow, cooking giant snails. They must have been a real treat. Or maybe just desperate for protein? What do you think?
Hard to say for sure, but it definitely shows how resourceful early humans were, using whatever food they could. And here's the twist. They weren't just eating snails. They were having them with a side dish. And it's not what you'd expect.
Okay, I have a feeling this is where it gets good. What was this mysterious side dish?
Potentially poisonous plants?
Wait, poisonous plants? Why on earth would they do that?
Remember, this is a time when survival was everything. Maybe they used the plants for medicine, or maybe they found a way to make them safe to eat. It shows how much they knew about their environment and the risks they'd take to survive.
It really makes you wonder what other surprises are hidden in the fossil record.
Absolutely. Paleontology is full of surprises, and it's constantly changing how we understand the past.
It is. And we'll continue to uncover more of those surprises after a short break. We'll be right back, so don't go anywhere. Welcome back. Before the break, we were talking about giant snails on the prehistoric menu. It's amazing to think about how adaptable those early humans were, trying anything to survive.
Absolutely. And those giant snails, they were pretty good at surviving too. You mentioned earlier wondering about what made them so successful, so let's dig into that a little.
Okay, so giant snails. Besides being food, what made them such good survivors?
Well, their size is a big advantage, literally. A bigger snail is harder to prey on.
Yeah, I guess a bigger shell would give better protection from the weather, too.
Exactly. More space to hide from the heat or cold helps regulate their temperature. But size isn't their only trick. Their diet plays a part too.
Right, we were talking about those potentially poisonous plants. Did they have a way to deal with those toxins?
You know, it's not so much a system for detoxifying, but more like a tolerance they built up. They evolved to withstand certain toxins, maybe even storing them in their bodies.
So they're basically turning their food into a defense. That's pretty smart.
It is. It shows how natural selection can lead to some really cool adaptations. Speaking of adaptations, we've been talking animals, but what about plants? Those poisonous ones the humans are eating, I bet they had their own ways to survive, too.
That's true. They weren't just sitting ducks, were they? I'm sure they had ways of defending themselves.
Absolutely. Think about it. Thorns, spines, bitter tastes, even those toxins, all ways to deter herbivores.
Like a constant arms race.
Yeah,
Right. Predator versus prey, always trying to outsmart each other.
exactly. And the environment is a big part of that, shaping how things evolve, the challenges and opportunities of the environment. They really drive evolution.
So how did those ancient environments we've been talking about actually shapes these creatures?
Well, let's take those speedy pandas. Their long limbs and that hunting lifestyle, they probably developed in an environment where speed was key to survival.
And the Etiocidus with its weird feeding style. Could that be because of the type of food available in its ocean environment?
Most likely. Imagine an ocean full of tiny creatures. Filter feeding would be a great strategy, leading to those special structures like baleen.
So the environment is kind of like a sculptor, shaping life over millions of years.
That's a great analogy. And remember, those environments were always changing, forcing life to adapt, to keep up.
It's amazing to think about all that time passing and all the changes that led to the diversity of life we see in the fossil record.
It's an incredible story, and there's still so much more to learn.
You mentioned earlier we talk about prehistoric childbirth. That's not something you hear every day. What can you tell me about that? Welcome back to the deep dive. It's wild to think about how even giving birth was a challenge for these prehistoric creatures. So what did those ancient births actually look like?
Well, the research has focused on ichthyosaurs, those marine reptiles that ruled the oceans millions of years ago. You know, for a long time, paleontologists just assumed they would have given birth tail first, like most reptiles. But new evidence suggests it might not have been so simple.
Really? So how were they giving birth then?
The research suggests that earlier ichthyosaurs, they might have actually given birth head first. And then, as they evolved and became more streamlined for that life in the water, they switched over to a tail-first birth.
Huh. That's fascinating. But wouldn't tail first be safer, especially in water? I mean, don't they need to breathe right away?
You'd think so, right? But when you think about how their bodies changed over time, it starts to make sense. Their necks got shorter, bodies sleeker. A head-first birth, especially in the water, might have been easier.
So it's another example of how evolution isn't always straightforward.
Exactly. It's full of these twists and turns, and studying them can teach us a lot about the pressures that shaped how a species evolved.
It's amazing how these little details can reveal so much about prehistoric life. It's like every discovery adds another piece to this huge puzzle we're trying to solve.
Absolutely. And the best part about paleontology is there are always more pieces out there waiting to be found. There's so much we don't know about those ancient worlds and the creatures that lived in them.
I think it's safe to say that our deep dive today has uncovered some pretty mind-blowing stuff and challenged some of our ideas about prehistoric life. Who knew pandas used to be speed demons? Or that ancient crocodiles might have had lips? Let's not forget those giant snail feasts.
It just goes to show you paleontology is full of surprises. And as we keep exploring the fossil record, who knows what other incredible discoveries are out there?
It's exciting to think about all those mysteries waiting to be unearthed. So to all our listeners who share our passion for the prehistoric world, keep exploring, keep asking questions, and keep digging deep. There's a whole world of paleontological wonders out there just waiting to be discovered. Until next time, farewell from the deep dive.